Okay, so we're here back in the directory of lecture 6, and I'm going to fire up the population nature model here on Vensim, and let's see what it shows you. Okay, so as I mentioned, this is a model that we're going to be using in the future. We're going to be altering this, and this is sort of the basis for the handy model that I've mentioned on a couple of occasions that we'll fully discuss next week. But let me walk you through this model. This model has two stocks, population and nature. Okay, and population is driven by births and deaths. Nature is able to regenerate, so there's a natural process by which nature gets replenished, and that has an upper bound in natural capital, and the availability of nature will essentially drive the death of population, and population will consume nature. So that's a two-way feedback. Okay, and let me walk you through the equations, through the math, or through the modeling equations. Anyway, start with population, and population is it's a stock. It's got units of people, and it's driven by the births and the deaths, the difference between the two, and it's got an initial value for population. Okay, that initial value of population in this case, it's here, and for the sake, purpose of an argument, it's 100,000 people to begin with. Okay, you can change that and see what happens. The nature stock, it's driven by a regeneration and a depletion, and it's got an initial value, and it has units of eco-dollars, okay, or ecological dollars, and the regeneration of nature, it's given by a logistics type equation where you have a regeneration rate times the stock nature, and then the difference between an upper bound, which is the natural capital, and nature. Okay, and this is done to essentially try to keep the model from overshooting from this sort of limit. And this natural capital has units of eco-dollars as well. Okay, and it's 1,000,000 eco-dollars. So this is sort of the stock of nature that you have to play with. Okay, so that's sort of the picture, and you can think about this as for all the people that work in ecosystem services, in biodiversity, this is meant to capture that concept. Okay, there's an initial nature value for nature, which is the capital. In this case, you can make it half, or you can make it more. We'll see how this reacts, but right now it's 1,000,000. It's got units of eco-dollars as well, and then the depletion is driven by the depletion of nature. Is driven by a depletion rate, the population of X, so the population that's depleting it, and then the availability. So it's a typical logistical form for nature. Now let me take a look at the births of population here. The births of population are given by a rate of population. These are people per year times the population, and then the birth rate is essentially 2% per year. Okay, so it's a growth rate of 2% per year. The death rate, you will see that it's the product of a rate of death coefficient in population, and it's got units of people per year. And the key to this model and the feedback comes through the death rate, because the death rate is limited by see here it is it's limited by the nature availability per capita. So the death is the maximum of two values. Either the minimum, death rate. So this is the minimum death rate, as we discussed before, is the death rate of people when there's no nature constraints. So essentially, there's plenty of nature per capita, so you're dying for natural reasons that are not related to the availability of nature. However, if nature is limited, then there is a little equation here, which is the slope. It's a sloping line that we showed before, where there's a maximum value. So there's a higher rate when nature is limiting, and is driven by the nature per capita. This nature per capita here is the ratio of essentially stock Y divided by stock X. So this is the amount of eco-dollars per people that are available. This is the amount of natural capital per people that's available. Okay, and that's pretty much it. The other parameters that come here are just values. You can vary them, and so the maximum death is 5% per year. This is when there's no nature. So if you run on natural resources, then 5% of people would die per year. Okay, and the minimum is I think it's 1%. It's 1%. This is the natural one. Okay, so again, you can run this model very quickly. And for some reason, I wanted to run this. For some reason, give me a warning, and I don't know what this warning is coming from. The model seems to run fine except for that warning. The results look fine. So I need to find out what that warning is about. But let me graph, actually not this, but let me graph population, and you can see these are the graphs that are in the lecture, and you can start seeing the population started at 100,000, and it went up a little bit, and then you start running out of nature, so it declined rapidly, and then eventually it bounced back. I guess at some point nature, the deaths were unaffected by the natural availability because they were so low, and then it sort of bounced back. And you can do the same with nature here. Look at the graph, and these are the graphs that I showed you before. So nature sort of shuts down, and then eventually when there's so little people consuming it, it sort of bounces back up, and in doing so, it sort of frees up the limit on the population, and they both stabilize. Okay, and so you can do that, and you can create a little custom plot very quickly. You set a graph. I don't think I created it, or maybe I did. I call it state variables, which you can look at. And these are, I think this is what I showed you before in the lecture. So, and also the values. So you can look at these two. So this is a fairly theoretical model, and the idea is to look at the interaction between the two variables, and this is going to be the basis of a more detailed model that we will refer to as handy, and we'll read about it. So I'm going to close this, and that's pretty much it for this model. Feel free to play around with it, get more results. Modify the parameters. One thing you can do very quickly is to run an input-output object and do a synthetic simulation, which essentially turns all these, let's say no, and let's call it something else. Let's call it variable inputs, or whatever you want to call it. Variable inputs, and if you do that, then you can turn all these knobs up and down, and it becomes a lot of fun. So I'll let you with that. I'll let you run this and post some results. I want you to play with it, become familiar, become very intimate with these models, because this is going to be the way you can create your own. Okay, so I'll stop here. I hope you enjoyed the lecture, and I'll be following this up with a commentary and putting everything on Facebook and on YouTube. Okay, take care.